Good morning, everyone. Thank you for joining us today. Today we have a guest, Richard Apodaca, Sales Director, and Diego da Silva, a Sales Executive for Uniwell. They will be talking about the autogenous equipment tips.
Good morning, everybody. Welcome. Certainly appreciate your being here today, this morning, and very appreciative. It figured I usually don't get calls. I'm very sorry. We'll cut that out. That's the home line, and so very appreciative that Galpa, in collaboration with Sencatech, brings these seminars to you. Hope you've been taking advantage of that. Very informative with all the info that they have to share with the industry. It's a great time to take advantage of this medium that they provide for us to enrich our knowledge, which in the end will help us to better do our jobs, better serve our clients, and definitely improve what we do from compared to what we may have done 2 months ago to what our work will be 1 year from now. So those are my contact details. If you ever have any questions, you can definitely send me an email on any technical or questions about our products, or even other just plain procedures, etc. Happy to respond to you with that. But any commercial aspects of it, definitely ask you to always turn to Galpa for that. They maintain an excellent inventory of our product line throughout our product line. So they're always attentively at your service in that respect as well. So take advantage of that. And for those that don't know, Uniwell founded in 1949, 70 years in the industry manufacturing here in Fort Lauderdale, Florida, north of Miami. So just a few shots from our factory. We're right by the Fort Lauderdale airport. If you ever come and visit us, you're more than welcome to do so. Although, give it about 3 months. Let's see how COVID-19 works out, because right now, obviously, there are a lot of restrictions and things we can and can't do. But in the future, let's say probably next year, you want to visit the plant, you're more than welcome to do that. Just coordinate with Galpa, and they can coordinate a tour with us here. That's our copper door, so you know that you've arrived at the right place. And inside, just sometimes some people that drop by unannounced were unaware that we're actually a manufacturing plant, very much a manufacturing plant. And just giving you a few shots of some of the equipment we use, some of the CNC machines that we use to produce the equipment that we offer to the industry. Our product line is divided into two sectors. One is the HVAC, which most of you are involved in, and the other is the industrial welding and cutting. With industrial welding and cutting, we can cut anywhere from up through 12-inch thick metal. We can weld up to 3-inch thick metal as well. So very extensive with respect to the product line that we do offer. This is our regulator line, and I do like to show this because this just shows that we basically test everything that we put in the market 100%, not just a certain lot, not 5%, not 10%, and then we say, okay, it's good, let's ship 100% of it out. We test 100% of every single thing that we sell. That includes brazing tips, that includes cutting tips, regulators, manifold sets, etc. So everything we do, we test 100%. When we talk about safety, and that's the topic today, we're talking about issues here with flames, with gases, flammable gases, with pressurized systems. Definitely themes and topics that you have to pay attention to. And you know, the safety really does begin in purchasing quality equipment. When you're dealing with these types of things, flammable gases, pressurized gases, you're dealing with high pressures. Why would you settle for an unknown manufacturer? I mean, it's your safety that's at risk, and not only yours, but your colleagues' safety as well. And so you endanger yourself, you endanger others, you endanger your employer. If you're a contractor, it affects the workflow. So it's very important to be cognizant of safety practices. And a lot of times we take this for granted. Um, so it really is important to pay attention to this, and we'll go through a few of the things that are important to keep mind of when operating with flammable gases. So in life, we know we see situations like this that even though we know they're not safe, we go ahead and do it anyway. Okay, in a situation like this, maybe the person falls down, breaks a leg, gets a few bruises, etc. But when you're dealing with flammable gases, when you're dealing with pressurized systems, you're talking about explosions, possibility of explosions, serious burns, loss of eyesight, and loss of life if things should go wrong. So it really does pay well to be a little bit more attentive to safety when we're dealing with oxy fuel. You're in another situation. Again, we know this is not safe, but the guy still goes ahead and props up the truck in that fashion. Here he is welding a gas tank. I just hope he remembered to empty the gas tank. So, you never know. Ah, my right arm here. I use this a lot. Used to before COVID-19. Used to travel all over the world. And why am I showing this? Because number one, I hope that in the near future I can resume my travels again, be out there with you guys, visiting and enjoying and the companionship that we have, and just helping with knowledge that I have as well, and imparting that with you. But I show this principally because we know that the pilots, every time they take off, it doesn't matter if they've had 50 flights, if they've had 200 flights, even on the 200th flight, they go through a checklist of things before they take off. It's automatic. They do this every single time, every single flight. So why don't we go through a checklist of things every time we're about to light up a torch? It's necessary to do that. We have 10 safety guidelines that it's always good to pay attention to. If you'd like, these posters are available and can be made available to you through GALPA. They can coordinate that with us. And definitely appreciate your being here. So maybe we can get some of these out to you as well to post up. But it's important. Each time you light up, you need to go through each of the safety checks. Just as a pilot goes through each of the safety checks before a flight, you need to go through the safety checks before you light up a torch and make sure everything's in order. So let's understand a little bit what creates the fire. Number one, you need a fuel gas. That fuel gas can be different gases, acetylene, propane, natural gas. And that combined with oxygen is what's going to start, gives us the ingredients to provide that flame. But in the end, we need a third ingredient, and that's the ignition source. Once we have the ignition source with those two gases combined, we get our flame. So if you eliminate one of those sources, well, once the ignition is started, you need to eliminate fuel or oxygen to cut out that flame. And typically what we'll do is we disconnect the oxygen first. We'll get more into that ahead. So what do we do with flame and heat? Well, we do the cutting. So not so much in HVAC do we have many cutting requirements, but there are some that do have that application. And of course, we offer portable kits with cutting attachments as well. But the majority of what we sell are just brazing equipment in HVAC. But this is available to you too. If you have a welding handle, a brazing kit, you can always add a cutting attachment to it. And then welding is that process of actually joining together the two pieces of metal. We're actually fusing the metal together and adding an alloy into it, into that fused portion. So this is a little different from brazing. It takes a higher heat. So we actually do fuse the metal here. Whereas in brazing, we're basically just joining the two metals together and using a filler alloy in the process. So here we don't fuse, in this case, the two copper tubes. We just join them with an alloy, which is going to give you that added strength in the braze joint. And then, of course, we can use it to heating, to form metals, to harden metals. A lot of times in HVAC, what we see here it is the copper that we use in HVAC. Um, some manufacturers of copper tubes preheat their copper tube before they send it out into the field. And so if it's preheated, it's easier to bend, easier to cut, and it's not going to deform when you bend it, when you expand it. If you have copper tube that isn't preheated, you need to anneal it, or in other words, you need to heat it up so that you can form it differently, so you can bend it and so you can swage it without it cracking the copper tube. So heating is an important process in HVAC as well when operating with copper tubes. Again, if you the brand of copper tube you use, it's important to know if it's preheated or not. If it is preheated, you're going to run into a lot less problems when bending and when swaging those copper tubes. If it's not preheated, it definitely is recommended that you heat up the copper tubes, anneal it prior to doing the swaging or the bending of the copper tube. So what type of gases do we use when we're talking about oxy-fuel? Oxygen is the principal gas that's used. Whether it comes from pressurized cylinders or from the ambient air, we're using oxygen. And it's important to remember that oxygen is contained in a cylinder at 2,000 pounds of pressure, very high pressure, over 2,000 pounds. So it's important to handle this with care. Oxygen by itself, actually, that's pressurized oxygen, is 100% oxygen. And it's not like the oxygen that we breathe from the air. The oxygen that we have from the air actually is only composed of 23% oxygen. The other percentage of what's contained in the air is nitrogen and other gases, but our oxygen from the air is only 23%. That's why it's very dangerous when it's 100% pure oxygen, industrial oxygen that's pressurized. So naturally, we shouldn't think that oxygen, industrial pressurized oxygen, is the same as the oxygen in the air. And sometimes we do get careless. We use it to blow off things because you have the pressure to wipe off things on your clothes. But no, if you do that, you're creating a very, very dangerous situation. For the reasons I explained, oxygen is 100% when it's pressurized industrial oxygen versus the 23% oxygen that's in the ambient air that we might be able to use. So you're going to mix that oxygen with different types of gases. Acetylene is definitely the most popular gas because it provides the most heat. On the downside, it is a very unstable gas and requires a special type of cylinder. So here we have a cylinder that's the core, a porous core that's filled with liquid acetone. This liquid acetone helps to stabilize the acetylene so that we can work with it. And of course, acetylene provides us with the highest possible temperatures when working with oxy-fuel. Very versatile in its applications, and you can do any job with oxygen and acetylene. But it's important to remember that the special composition of the acetylene cylinder is very different from a nitrogen cylinder that's hollow or from an oxygen cylinder that's hollow. Here you have that nucleus, that porous core that's filled with the acetone to keep the acetylene stable. There are a few safety requirements that we look at when emptying an acetylene cylinder. It's good to keep these in mind. Pressure of acetylene is never above 15 psi. If you need greater flow, for example, if you have several stations in a plant, etc., you might need greater flow, and then you need a manifold set to distribute all those gases among the different stations. But you never raise the acetylene pressure above 15 psi. So it is a low pressure gas as compared to oxygen or nitrogen. And one of the things, as we just saw with the cylinder, it is a special cylinder. So because of that core that it has and the acetone that's filling that core, if you lay it on its side, you're not going to get the proper mixture with the acetylene. So when you put it upright, it's going to take some time for it to all mix together. So it's never a good idea to operate an acetylene cylinder right after it's been mined down. You need to let it sit, let it stabilize a while before you can actually use that acetylene cylinder. Because as I mentioned, acetylene definitely is a very unstable gas, and it needs to be stabilized by mixing with the acetylene in that core inside the acetylene cylinder. So you have other gases as well. Each one's going to have their own special properties, and and they're used for a variety of different reasons. Propane, and these are the operating temperatures that you're going to get. So propane and air, oxygen from the air is going to give you those temperatures. MAP also will provide you with 2400 degrees. That's combined with oxygen from the air. And then we get into acetylene and air, and that will provide you with a little higher temperature. Very good for use in HVAC. The acetylene air equipment in the United States is a very popular equipment in HVAC, not so much outside the US and Latin America and the Caribbean. It could be used more, and the advantage of that basically is you're using only one cylinder, and that's the acetylene cylinder. The oxygen's free. You don't have to pay for recharge for the oxygen cylinder because you don't have one. You're using the oxygen from the ambient air. So acetylene air is always a good option to take a look at as well. And you're carrying less weight with only one cylinder versus the two cylinders. And then finally, acetylene and oxygen is the one that gives you the highest burning temperature. And of course, those temperatures will depend on the alloys that you're working with. What's the application temperature of the alloy that you're working with? If you're trying to fuse metals, what is a recommendation for the temperatures to achieve that? Most of them will be able to be, all of them can be achieved with oxyacetylene. Some and many can be achieved with acetylene air. In HVAC, most applications can work with acetylene air as well if you have the proper and correct equipment for that. So when we talk about fire care and prevention, this is common knowledge. We know we need to keep our working areas clutter free, but I've seen too many places where that's not the case, and we have oily surroundings. So always good to keep a fire extinguisher on hand, and also that the area is well ventilated, because we're dealing with oxygen, blending it with metals that can create fumes. Not only the metals, but as well as the alloy that we're using to braze or weld will let out some fumes. So it's better to be in a ventilated area whenever possible. If not, use a ventilating system to exhaust the fumes to better protect us. So when we talk about equipment setup, it's very important to inspect the cylinder valve seats. We're going to inspect threads on everything for damage, oil, grease. It's important that these threads be intact and as new as from the factory, because if they're scratched, if they're damaged at all, then you're not going to form that seal that you need for to avoid leaks. And we're, again, flammable gases. We're talking about gases that can displace oxygen as well as flame up. So we want to avoid leaks. It's important to have those threads in perfect condition when we're connecting. A lot of times we use Loctite for threads. We really shouldn't need Loctite if our threads are good, and if the threads are seating properly into the tool that we're threading them into. If those are perfect, we shouldn't need the thread to be able to seal that up. So what's the process when we start? Before we even connect a regulator to the oxygen cylinder, we want to crack the cylinder valve open real quick and close it. This is to blow off any grains of dust or dirt that might be on the inside of the valve that you might not be able to see physically. We don't want that to get trapped in between the cylinder valve and the regulator and have it travel through the regulator, and therefore it could damage the seat of the pressure regulator. So you want to make sure you do crack it. You want to stand opposite of that when you're doing that, and make sure nobody's in front, of course, of the pressure that's going to be coming out. Now, regulators do exactly that. They bring a high pressure from the cylinder into a working pressure uh, through the regulator. And I've noticed in the field in HVAC, for example, this particular adapter, I don't know if you're familiar with it. I hope not. And this is an adapter that I've seen in many different places. And here it's showing a connection to the nitrogen cylinder, and on the other, and then we connect a quarter-inch hose to that adapter, and on the other end, it's connected to the manifold set. Well, manifold sets aren't made to withstand 2,000 pounds or more of pressure. That's what's coming out of that cylinder. So you're going to damage the equipment, number one. But number two, you're putting yourself in a dangerous situation where you could blow the manifold regulator apart, etc. So not a good thing to do. You should be using a pressure regulator. Inspect threads on the regulators. Again, we're doing that. You shouldn't force it onto the cylinder valve. Uh, and threads are important on everything that we do. And before we even connect the regulator onto the oxygen cylinder or the acetylene cylinder, we want to make sure that it is not under tension. So we're going to release the tension on the springs on the inside of the pressure regulator. And we want to stand to the side when we're operating this. Why do we stand to the side? Because if there's any irregularity, if we've done something wrong, that explosion that could happen from the regulator or the gauges is going to go backwards or forwards. If we're at the side, then it's not as big an issue. We'll be a little bit more safe in that situation. So to avoid this, we want to follow the rules and the precautions that were previously mentioned and keep ourselves safe. With the different fuel gases or the different oxygen, with oxygen, we open that valve completely. Whereas with a fuel gas, we're not opening it up completely, perhaps just one turn. And if the cylinder valve has a key, such as on the acetylene cylinders that we offer, the portable acetylene cylinders with our part number MC, that's 10 cubic feet, a lot of times you need a key to open and close the valve. So that is always recommended to keep that on should you need to shut it down very quickly. When we talk about hoses, they're color coded for their specific gas in the US and throughout much of Latin America and the Caribbean. We use the red and green hose, with the green being oxygen and the red being the fuel gas. In some parts in the Caribbean, you're going to have the European code, which is an orange and blue, the orange being for the fuel gas and the blue being for the oxygen. And of course, connections on oxygen are right turn, and for the acetylene, it's going to be a left turn. Anything we connect, we always want to purge. We do a lot of purging here because we don't want gases to mix up. We want to make sure that when we ignite that flame, when we start the flame, that everything is in, that we have pure acetylene that we're running through one side of the hose and pure oxygen that we're running through the other side of the hose. So just in the purging manner, we open and close the valves and make sure that we're getting a good purge in a ventilated area. Torch handle, we're going to do the same thing again. Threads, here we go again, inspecting them, and because we want to make sure that the nozzles, the tips, sit properly onto the torch thread head as well. On the end of the hoses, or where we're going to connect check valves or flashback arresters, those threads need to be in proper condition as well. Welding nozzles, select proper type and size for your application. This is critical because if you want to avoid flashbacks, this is probably one of the key factors. A lot of times we have situations where we might be changing the size of a welding nozzle or a cutting nozzle, and we change the size from one size to another. It's important to know each size, what is the pressure of gas that's required for the fuel gas and what's the pressure of gas that's required for the oxygen. If you don't have proper pressures, you could possibly create this flashback or reverse gas flow, and that's going to create dangerous conditions. Also, with the welding nozzles, brazing nozzles, we hand tighten those because they have O-rings on the inside. You don't want to tighten them up with a wrench or you'll damage the O-rings. So that's important to always hand tighten the brazing or welding nozzles. And here, the tip charts that we offer assume 25-foot hose length, and then we're going to add 3 psi for each additional 25 foot. And in our catalogs and with the tips, you should get pressure information as well. Here you can see a Type 4 series tip. On the very left-hand column, it says complete assembly part number, and you'll see Type 4-1, -2. So those dashes pretty much indicate the size of the orifice that tip has and how much heat it's going to be able to put out. But then you have the column on the right side with oxygen and acetylene. It shows the pressure that's required. You can see on the very last one, the -8, you're going to need 19 psi of oxygen and 12 psi of acetylene. Whereas on the 000 at the top and on through -2, you only need equal amounts of oxygen of acetylene, much less, only 5 psi of each of the gases. So it's important to know your tip chart, your pressure that's required to work with the tips that you're using. Because if you don't have proper pressure, you can create those flashbacks. You can create reverse flow of gases also, and we don't want that happening. So basically, again, here we're just purging everything and making sure that everything's in proper order. We purge. And also, we always want to use correct protection. Important to use the safety goggles, gloves, especially if you're doing welding or cutting to keep your hands safe from slag and other processes from the overheating that we're doing on the metals. So it's important to use proper protection. We all know that this obviously isn't all that safe. It's probably very inexpensive, but I doubt he's going to get much protection when doing that. Lighting the torches. Here, basically, I just want to talk about the difference between air-fuel torches. Here, we're going to basically have full gas flow with the air-fuel torch. We don't light it at a low pressure. We light it with full gas flow coming through. And that's the way it's operated, because we want to push the flame away from the tip so it doesn't get damaged. With oxyacetylene ignition, we need to ignite first the fuel gas. And if we're using acetylene, we want to use acetylene and light that up first, and that will be followed by oxygen. And then you have your different types of flame, carburizing more acetylene, oxygen, more oxygen, and neutral flame. You're going to use that basically for heating for the most part. So as I indicated, always light your fuel gas first. And in case of an emergency, you want to do the opposite. You want to shut off the oxygen first. Otherwise, you'll get a big pop if you shut off the fuel gas first. And we don't want pops or odd sounds when we're operating oxy-fuel equipment. Cutting attachment, I'm going to go real quick through this. It's the same thing as a welding handle. Again, we're inspecting threads, and we want to hand tighten the cutting attachment onto the welding handle for the same reasons. That again, you have these O-rings that can get damaged if we're using a wrench to tighten the cutting attachment. So always hand press that. Again, we're going to purge, and as I mentioned, no pops. Small flames that cling to the tip. Acetylene valve is leaking, and this goes for cutting attachment as well as the torch when you're welding. If at the end of the tip, whether it's a cutting tip or a welding tip or brazing tip, if you have that little yellow flame after you've shut it off, that means you have a gas leak coming through the valve that opens and closes either on your torch handle or on your cutting attachment, and that needs to be repaired. Reverse gas flow. So we want to avoid the gas flowing back to the cylinders. We're pushing from the cylinder acetylene and oxygen out to the torch tip where it'll be ignited with a flame, and we need to keep it going in that direction. We don't need reverse gas flow. One of the areas where this happens is we try to economize and use up our gas completely in the cylinder, but that creates an imbalance of pressure and allows, for example, if the oxygen cylinder is emptied, it will allow pressure of the acetylene to push through on into the oxygen side and can contaminate the oxygen hose with acetylene. It can contaminate the oxygen regulator with acetylene, and in the end, it can contaminate the oxygen cylinder with acetylene. So we don't want that gas flow going backwards, and you get into very dangerous situation there. Yeah, to the point that if you don't have an explosion, it can create issues, burning the hoses, and damaging other components. So with that, I want to show just this quick video here. It'll talk about that.
Assume that while you're using a torch, you deplete your oxygen supply so there's no pressure or very little pressure remaining in the cylinder, regulator, or hose. The fuel gas, still under pressure, will now take the path of least resistance and travel back up through the torch into the oxygen side of the system. The oxygen side of the system is now contaminated with fuel gas. When a new full cylinder of oxygen is connected and the cylinder valve opened, the heat generated by the pressure of over 2,000 pounds per square inch entering the regulator may be sufficient to ignite the fuel gas present in the regulator, causing a fire or an explosion. And even if a fire or explosion doesn't occur when the cylinder valve is opened, the dangerous condition still remains. If the torch is relighted without first purging the hoses, a rapid burnback could take place, damaging the torch, the hose, and possibly the regulator.
So you can see the situation there when you do have that reverse gas flow, just the dangerous conditions that it represents. So how do we avoid that reverse gas flow? Well, the most economical method of doing that is to use check valves. And I do recommend that you at least have these on your welding handle. That you have at least reverse check valves on there, particularly if you're in that custom of always emptying your cylinders. This way you can avoid the situation that we just saw in that video. Because it'll allow the gas just to flow in one direction. They do become clogged, so it's important to check them periodically and to make sure that they're operating correctly. So flashbacks, this is when a flame will actually come back from the tip, from your flame point back into the tip, into the torch, and can work its way back through the hoses, on through the regulator, and even onto the cylinder, creating extremely dangerous situations and an explosion. Here's a situation of a cutting torch with a flashback. You can see how it burned. Actually, that bottom part, the black part, that's where the mixer is in this particular equipment that mixes the gas with the acetylene for the heating process. And you can see how that just got burned internally. And of course, these are the seats that are damaged during that flashback. This is a safety torch, so to speak. It doesn't have that internal mixture. The mixture is done in the seat, in the cutting nozzle, so much more safer than the other design. We offer different designs to meet with the preference of our customers' requirements. Flashback causes, so clogged tips will restrict gas flow, so that can create a flashback. Loose tips. Now, the cutting tip does need to be tightened with a wrench. So you want to make sure that that's on there tight. Damaged O-rings or seating, that can be between the welding or brazing tip onto the welding handle. That can be the connection between the cutting attachment and the welding handle. So we need to make sure that everything is in proper order. Excessive reflective heat. If we're putting the tip too close to the metal that we're brazing, then that extra heat can work its way backwards, and that's when we're going to create a flashback. And then, of course, not having the proper mixture of fuel to the tip, as we saw on the tip charts, is important. Otherwise, that also can create these flashbacks. And that flashback, it basically the flame speed is going to exceed the flow rate of the gas, and that's the way it works its way back. So the flashback arresters will actually. Why do they call me at this time? They shouldn't be calling. Sorry about that. Uh, so any sounds, we always want to cut off that oxygen right away and just shut down the system. So don't hesitate to do that. You can figure out why it's happening afterwards. Don't try to figure it out while the sound is ongoing. So we shut off the oxygen, and that way the flashback will extinguish itself. We've already talked about tip sizes and how important that is. And just some flashbacks there I want to get through. Important to know that the flashback arresters do include the check valve as well, so it'll also avoid the reverse flow. Like I mentioned earlier, the more economical option is the check valve, and I suggested at a minimum have check valves, especially if you're accustomed to emptying out your cylinders. But the flashbacks will actually extinguish the flame, and that's what stops that fire from being created further back from where that flashback point is. It's important, again, that you use recognized flashback arresters. Just as I talked at the beginning of the seminar here, I mentioned we're working with pressurized gases. We're working with flammable gases. Why would you purchase brands that are unknown to you? Buy from reputable manufacturers. We're talking about safety here. We're talking about our livelihood. Same thing with the flashback arresters. It's important that you use quality brand flashback arresters, because if it's an unrecognized name and you don't know the manufacturer, you don't know if that's going to work for you when the time comes. And of course, we need to make sure that they do work when they're called on into action. This video here will actually demonstrate how check valves are used to avoid a flashback. They won't. He actually puts 5 check valves in succession, and that still doesn't stop the flashback. It'll be self-explanatory here. And then he'll operate with a flashback arrestor to demonstrate that.
Here's the gases. They're flowing through my little device here, which has a clear crystal, a quick connector, and a clear hose. I'm going to ignite these gases, and we should see an explosion going back down the hose, through the quick connector, through the clear crystal. It's going to be a loud explosion. I think you could see the flame going through the hose, down through the clear crystal. That is the flashback. What this flashback can mean is the flashback would move back down the oxygen or the fuel gas hose, back into the regulator, into the pipeline or cylinders, and cause a very serious explosion and fire, injuring, maiming, or killing employees, doing a tremendous amount of property damage. That can be prevented by a safety device, which I'm going to show you in just a few moments. Common throughout North America, we find something called a check valve. This is a common safety device in a lot of areas around the world. I'm going to test this safety device and see if 5 check valves, reverse flow valves, can stop the flashback. Same phenomena as before. I'm going to use the same settings on my torch as I did before. Same mixed gases flowing down the hose through the clear crystal, this time through 5 check valves or reverse flow valves in a row. 5 times the protection you might find on a regulator or a torch. Let's see if these check valves stop the flashback. As you can see, the flashback went right through 5 check valves in a row. Graphic demonstration that check valves were unable to stop the flashback of welding gases through the hose. These devices will not offer you the protection you need for 3 reasons. First of all, they can become clogged very quickly because they do not contain an inlet filter, and dust or dirt, talcum powder in the hose will cause the check valve to leak. Number 2, these require an inspection every 6 months or more frequently in abusive situations, and most people, frankly, do not check them. And finally, if mixed gases get ahead of the check valve, upstream of the check valve, they have no way to stop a flashback. That's why these devices alone cannot offer the degree of protection that the device I'm going to show you now can. And that device is something called a flashback arrestor from Ivita. The flashback arrestor contains both a check valve, a sintered element that stops the flashback, and in the case of the regulators, models contain a thermal shutoff. Same setting as before. Same setting on my torch. And again, it doesn't matter if I was using a welding torch or a cutting torch or even a heating torch. The phenomenon of the flashback can occur. Same setting. My gases are flowing through the device, through the clear crystal. Now, if the Ivita flashback arrestor performs its job, we're going to see a flash of light, the flashback, come back to the flashback arrestor and stop dead. We will not see it in the clear crystal. Let's see. As you can see, the flashback occurred here, went down the hose, and was safely stopped by the Ivita flashback arrestor. This particular model is for regulators. They're available both for regulators, for torches, and even for inline.
So that gives you an idea of the importance of using flashback arrestors. And as I said, at the very least, check valves, if nothing else. Yes, flashback arrestors do cost more, but definitely they'll protect you a whole lot better. So if you're using acetylene, oxygen, I highly recommend that you do use the flashback arrestors just for your own safety. When shutting down, basically, we want to make sure that we exit the gases from the system. Do not leave the regulators under pressure. One of the things I do see happen quite often is, let's say between shifts, they might leave the pressure on the regulator. The user might leave the pressure on the regulator, and they'll just shut off the gas on the cylinders. Well, if you do this, let's say you leave the pressure contained inside the regulator, next user comes and they open up that cylinder. What they're doing, particularly on the oxygen, they're letting, again, 2,000 pounds of pressure or more enter into a regulator that's already under pressure. This is kind of like a rat trap under pressure. And here you go, hitting it with another punch. And that's where these dangerous situations of explosions can happen. So it's always important to release the tension in the pressure regulators. Make sure it is not under pressure once you've finished your shift and are done working with that. So we always want to read operating instructions. I know it's easier said than done, especially if you've been working with this equipment for quite some time. But again, flammable gases, pressurized gases, I think it's well worth it to take a look at the instructions from time to time, make sure we're doing everything as we should be. You want to keep the cylinders changed and upright all the time, particularly the acetylene, as I mentioned, very important. And we want to stay away from grease and oil and clutter, just for our safety. And again, just use the check valves or flashback arrestors. We always want to use the proper size tips for the job that we're doing and use the proper pressures, purge, and keep areas well ventilated. So protective clothing, again, this is an issue. Don't always have the best protective clothing, but things are not safe here. This, you might wonder what this has to do with anything. Well, actually, it's a gas issue, because if this guy releases some gas, I'm not sure what the situation will be there. So not exactly an oxy-fuel issue here, but definitely it could be a gas issue. Again, we sometimes do things we know aren't safe. We shouldn't be doing them, and that's when we get hurt, when we do these things. So always keep that in mind. And again, keep oils away from everything. Even in HVAC, when brazing copper tubes, you should have oil on the copper tubes. If you have oil, even if your hands have oil on them, and you have touched the copper tube and you just want to braze the copper tube, the alloy will not flow and bind where your hands have touched, where your oily hands have touched the copper tube. So you're going to have a weak joint. So it's always important to work with clean metals to begin with, and definitely keep oil away from everything. We always want to keep everything operating properly and in good condition. And basically, if we go through that checklist, as I mentioned at the very beginning, and everything becomes instinctive, just as it is with a pilot before he takes off for flight, then the work will be much more efficient. We'll keep the safety for ourselves, for our colleagues, and for our employer, and keep the business running safe and sound. So very important. I hope some of these tips have been helpful for you. I'm going to end the slides for now. If you do have any questions, please let me know. I think you can answer that through the chat if you're following on social media, or you can type it in here as well. So
thank you, Richard. I appreciate all the information that you have shared with us. The audience, you have any question, please send it via chat, or if you have any other question after, you can always email us to info@sencatech.com. There in the screen, you can see the email. You have any further question afterwards. Well, we want to close the session now. Remember, if you have any question, you can always send it via email. Richard, Diego, thank you very much again for all the information that you had shared with us, and see you next time.
all right, thank you very much, and everybody take care. Until next time, bye-bye.